This conference will now be recorded.
So good morning, everyone. Welcome to lecture 7 on pre-stressed concrete structures. So I would like to, conclude the things what we learned from the first module, right? So in that introduction, we already gone through a lot of topics like historical development, types of pre-stressing systems, devices, stages, and all. What are the advantages and limitations of pre-stressing system? And what are the high grade concrete and high grade steel, and what are the characteristics towards pre-stressed concrete structures. Okay, so these are the topics, I mean, including the materials of pre-stressing. Okay, so these are the topics which we covered in the first module. So let me start the second module. So second module consists with the two subheadings. So one is on pre-stressing methods, second one is on pre-stressing losses. Okay, so second unit is very important. It's gonna take time. Okay, so to complete the second unit, because that unit is very important, where you are going to understand the methods which are required to do pre-tensioning and post-tensioning of the structures. Okay, so now let me show you what are the contents there in the second module. Okay, then we'll start further. In the second module, the first stage, I mean the first part will consist with methods and systems of pre-stressing. Okay, so here pre-stressing, in the sense we are doing pre-stressing in terms of pre-tensioning and post-tensioning, isn't it? Right. So here pre-tensioning and post-tensioning methods and systems of pre-stressings are listed over here, where there are 5 systems. Okay, Hoyer system, Magnell system, Freyssinet system, Gifford-Udall system, Lee-Meccal system. Okay, so these are the 5 systems which are available to do pre-tensioning and post-tensioning in the form of a pre-stressing technology. Okay, in that it clearly defined Hoyer system is the one which is applicable to do pre-tensioning. Okay, so if you want to do pre-tensioning, you have to follow the Hoyer system. So that Hoyer system will explain you what are the stages and how you have to do the pre-tensioning. Okay, that is what the system really means. One second. Okay, and the next one is Magnell system, Freyssinet system, Gifford-Udall system, and Lee-Meccal system. So these 4 will explain you how to do the post-tensioning of in pre-stressing concrete. Okay, so in that way the systems was classified. So we will try to explain, I mean we will try to go through one by one. Okay, so in that, what do you mean Hoyer system? What are the advantages and disadvantages of Hoyer system? How this Hoyer system is applicable towards doing pre-tensioning? Okay, that everything we are going to study over here. Okay, right. So that is the first part of the second module. Let's go with the second part of the second module, which is loss of pre-stress. I mean pre-stressing loss. See, whenever we, a body is subjected to load, so definitely there will be some losses takes place, isn't it? Say for example, when a beam is subjected to load, due to some kind of disturbances, there may be some loss. Okay, that loss will leads to decrease its strength. Okay, so in that way, even the losses of pre-stress are also going to define here very clearly in terms of pre-tensioning and post-tensioning. Okay, so here the losses of pre-stress in pre-tensioning and post-tension methods are due to various causes. What are those causes? First one, elastic shortage of concrete. Okay, second one is shrinkage of concrete. We already gone through what exactly the shrinkage, how the concrete is going to be shrink. Next one is creep of concrete, relaxation of steel. Okay, what do you mean relaxation? We call it as a resilience. Okay, so what do you mean resilience? Member will store some energy to regain its original shape and size. So when it is regaining, so there will be some relaxation takes place. So that relaxation will lead to some loss in pre-stressing. And the next one is slip in anchorage, bending of member, and frictional loss. Okay, sorry, here slip in anchorage is the one and the bending of member is the other one. Okay, both are not same. Yeah. Okay, so bending of member is one of the loss. Due to bending also there will be pre-stress loss takes place, and the final one is frictional loss. Okay, so every body, so when there is a bond between two members, so definitely there will be some friction takes place. So that friction also will create some loss in the pre-stressing. Okay, so in that way your module 2 was classified into part A and part B, where it is talking about methods of pre-stressing, and second one is loss of pre-stressing. Okay, so this loss of prestressing we are going to continue after completion of the methods. Okay, so this is what about the second module completely. Very important. Okay, so even in the interviews if you go, so definitely they're going to question you the methods and losses. Very important unit of mind. Okay, so I hope you all understood what exactly the prestressing, everything, right? So then you can able to understand this second module better. Okay, so I hope you already gone through the first module clearly. Yeah. So next, so here before starting about the different methods of pre-stressing, here let me tell you in pre-stressed concrete structures, here the pre-stressing, the term is introduced by what? Stretching steel wire and anchoring them against the concrete. Is understand? So here the pre-stress, the term is introduced by what? So how you can do stressing over here? By stretching steel wire, or by stretching strands, or by stretching tendons and anchoring them against the concrete. Okay, then your concrete will be induced with some compression stresses into it. So therefore this pre-stressing system should comprise essentially a method of stretching. Okay, stretching the steel, and the method of anchoring into the concrete. So you have to remember two stages in pre-stressing. Okay, so in pre-stressing the principle behind that is two things will be taken place. One is stretching of steel, the second one is anchoring into the concrete. Understand? Okay, please try to remember these two important terms: stretching the steel and anchoring that steel to the concrete. Okay, so that is what about the pre-stress term exactly means. So here there are different systems are adopted for pre-tensioning and post-tensioning. Why these many methods? So why can't be one method which is gonna be accurate and which is supposed to be used for pre-tensioning and post-tensioning? No, every method is having few advantages and disadvantages. In that way, for pre-tensioning there are 1 to 2 methods and systems are there, and for post-tensioning there are around 4 methods are there. Okay, so that's the reason why we have to go through all different systems. Wherever based on the application based on the application, so you have to opt the type of system which is going to be useful for that particular instant. Okay, so in that way you have to go through the all the systems, and you have to know what are the advantages, what are the benefits, what are the overview of each system. Then only you can able to make use of that particular system for your application. Understand? So this is what about the pre-stressing different systems. Okay, first let me talk about the type of pre-stressing systems. For first we will go with the pre-tensioning system. For pre-tensioning system, okay, so there is a method called Hoyer system. Understand? So already we gone through the different type of systems, right? In that first system is called a Hoyer system. Hoyer system can also be called as a long line method under. Okay, long line method. Why it's so called long line method anedi I will try to show you in picture. Okay, then you can able to understand it clearly. So pre-tensioning is gonna be done with the help of Hoyer system. Okay, so which is gonna be often adopted in pre-tension. So for the applications of pre-tensioning, what are the applications of pre-tensioning? Tell me. Railway sleepers, electrical poles, precasting panels. Okay, so I mean crash barriers. So like that, very small elements in a huge production, they are all going to be pre-tension, isn't it? For doing pre-tensioning of that particular arrangement, you have to go with Hoyer system. What this Hoyer system is explaining, okay, what exactly about this Hoyer system? Here there are two bulk heads, it can also be called as abutments, independently anchored to the ground, okay, so which are going to be provided several meters apart, let us say 100 meters wide, so which are going to be structured between the bulk heads. So heads means, so for doing pre-tensioning, your heads will be on either side, one on this side and one on the other side. So you are going to be anchored, okay, the wires to that particular heads, and the molds are going to be placed enclosing the wires, isn't it? Then the concrete is going to be placed surrounding the wire. So what do you mean pretensioning? Here the pretensioning is the one which are going to be done before the concrete casted, isn't it? So we all know what exactly the pretensioning is. So here the same thing in this Hoyer system, what it is telling about, you are supposed to be anchored independently to the ground for a length of say 100 meters wires, which are going to be stretched between the bulkheads, okay, and then the mounts are going to be placed enclosing the wires, and concrete is going to be placed in between the wires or surrounding the wires. So that is how the Hoyer system is clearly defining. So with this Hoyer system, what happens, several members can be produced along one line, understand? Ante, so if you want to produce five, I mean if you want to do pretensioning of 5 to 6 elements at a time, understand? For example, take a one railway sleeper, okay, doing pretensioning of each individual railway sleeper, it takes time, isn't it? If I want to do pretensioning of 5 to 6 railway sleepers at a time, which method is optimal? So you can go with Hoyer system. Hoyer system em cheptundi ante, at a time you can able to do pretensioning of 5 to 6 elements at a time. So that is the advantage, and that is what the Hoyer system is clearly explaining. So that is the reason why Hoyer system is also called as the long line method under. Okay, long line method ante ఒక 100 meters length wire ni మనం stretch చేసి in between you can place around 6 to 7 molds, and you can cast all 6 to 7 elements at a time. Okay, so I will try to show you one video and picture also how this Hoyer system or long line method is going to be optimal. Okay, so here please try to understand, for doing pretensioning, what exactly the Hoyer system or long line method is clearly explaining you. Okay, so with this Hoyer system, several members can be produced at along one line. So this method is economical and is used in almost all pretensioning factories. So that is what an advantage of Hoyer system. Why? Because at a time you are doing pretensioning of around 5 to 6 elements, isn't it? So by that, can't you say it is an economical one? Exactly. So doing all elements at a time within the length. So by that, this method is going to be an economical and is going to be used in almost all pretensioning factories nowadays. Okay, so that is what about the Hoyer system or long line method is going to be derived. So now you can see what exactly the Hoyer system is. See, let's try to see the first picture. Please follow my cursor. This is what an abutment. This is also an abutment. In between abutment, there are 3 elements. 1, 2, 3. Okay, understand? So these are not the names of these elements, right? So they are just the notations of materials which are available in between the abutments. So this is an abutment. This is an abutment. There are 3 beams, I can call it as, or there are 3 elements. Let us take these are all railway sleepers. See, all these 3 railway sleepers can be pre-tensioned at a time. How? By placing all in a single line. That's why it is called a long line method. In this long line method, I placed all 3 elements in a straight line, and the same wire is gonna used to pre-tension of these 3 elements at a time. Okay, so this dotted is called tendon. So these 3 elements are called beams, and this is what an abutment. At one abutment, the strand or a tendon is going to be anchored. Okay, the fixed one end is fixed, it is anchored here. This end is free. Now this end we are going to apply hydraulic pressure to pull the strand, pull the tendon, or to stretch the tendon. Understand? Okay, so this is what exactly the Hoyer system is talking about. Okay, so with the help of hydraulic system, with the help of the jack, you are stretching this wire. Okay, then the strands are going, tendons or strands are going to be under tension. Then after you are going to pour concrete. Then after concrete gets set, you are going to cut the both ends of the wires. Then the compression forces will be induced into the concrete. That is how concrete is going to be pre-stressed. Understand? So this is what about the Hoyer system in pre-tensioning. Okay, so here you can see for each individual member how the Hoyer system is applicable, right? So you can see this is called wedge, this is called tendon, right? And in the left picture also you can see this is what an element, this is the distribution plate, high tensile wire. Okay, sandwich plate. What do you mean sandwich plate? So if you want to pull the wire or a tendon or a strand, okay, it should be plucked with some kind of plates. Okay, so that is why it is called sandwich plate, to pull the strands and matter. And there will be steel wedge. What do you mean wedge? What is the purpose of the wedge, Amma? Wedge will hold the wire, okay, without any slip. Wire slip avvakunda hold chestund anamata wedge. So that is the purpose of the wedge. Okay, now let me show you one video how the pre-tensioning can be done. Now you can relate this Hoyer system easily with this video. Okay, right. Now whatever we spoke till now, right, please try to relate everything with this system, right? So now they are creating the base. So that is mold. Okay, so now you can see how many elements are placed here. 1, 2, 3, 4. That means 4 panels or 4 elements are going to be pre-tensioned at a time. Okay, so this is what the long line system is going to be useful. Okay, please observe carefully. The same wire is going to be continued from this end to that end, where it can do pre-tensioning for all the panels at a time. See, a single unit where it can do tensioning. Malli chudandi okasari. See, have you observed? Right, now all these tendons or strands or wire, whatever it is, so all are all pre-tensioned now. Okay, so after tensioning, concrete is going to be poured in between. One second, guys. So let me put charging. Actually, charging is down. Sorry. Okay, so now you can observe. So when the concrete is poured surrounding the wires, right? So this is one panel. So like this, all panels are casted at a time. all panels are pre-tensioned at a time. Okay, see what they did, now. What is this? Something which is laying on the surface and some red sparks or red, what is this? So why these rods are red in color now? What they are doing, they are heating the rods. With that, steam will generate. Through that steam, the concrete will be cured fast. Cured and set, it will set fast. So by that you can remove the mold within time. Okay, so within 24 hours or within with the help of this steam curing, thermal curing, you can decast or you can remove the mold within hours and matter. Okay, so that's the purpose of placing rods below the casting elements, okay, to remove the formwork within hours, right? So that is the purpose of using the rods below the mold, so where they are all completely thermal cured. So now panels are ready. You can lift the panels, you can cut the strands for each individual member, right? And you can make use of these panels for using, for the application. See, with the help of some crane kind of thing, you can lift the panel and you can reuse the mold for the next panel. Okay, so this is what the Hoyer system is talking about. Okay, right. I hope you all understood what exactly the Hoyer system and why it is applicable for pre-tensioning. Clear? Guys, please respond. Andarki ardhamainda? You can answer me either through voice or through message. Because
Yes,
if you understand this, then I can continue.
yes, sir. Understood, sir.
అందరికి అర్థమైందా? గుడ్. వీడియో అందరికి అర్థమైందా? లావణ్య, మోహన్, నిఖిత, ప్రవళిక, రమ్య, వంశీ, గోపి, ఇండస్ట్రీ.
Yes, sir. Understood, sir.
Everyone. Ever get
Yes, sir. Yes, sir. No, sir.
Good. Right.
No doubt, sir.
Okay, ma. Clear. Then I can continue now. Okay. So this is what exactly the Hoyer system and which is adaptable for doing pre-tensioning, okay, of the member. So now let me go with a few more points in pre-tensioning system. For doing tensioning here, what we are using some kind of hydraulic jack, isn't it? So for doing tensioning, we are using hydraulic jack in Hoyer system, and the wires are gripped at the bulkheads using split cone wedges. అర్థమవుతుందా? ఇందాక మీరు ఏదైతే వీడియోలో చూసారో, for pulling we are going to use some hydraulic jack. When you are pulling, that strand is supposed to be gripped with some device. That device is called wedge anamata. Okay, so these are all wedges. So okay, so wedge ee vidhanga kanipistundi anamata. See, if you see the wedge is splitted into 3 pieces. Wedge anevi 3 pieces ga untayi anamata, right? So you can see the clearly how the wedge looks like here. So this center portion is called strand. Each rod is called wire. Okay, when you are winding all the wires, we will get a strand. This strand is supposed to be gripped with the wedge. This wedge anamata. Okay, so around the wedge, this is called bearing plate, right? So this wedge will hold the strand. Okay, this bearing plate will hold the concrete to be get compressed. Concrete compress avvadaniki aa bearing cone gaani, bearing cone gaani, aa bearing plate gaani manaku use avutayi, right? So here what is the statement? For tensioning, the hydraulic jack is going to be used. Wires are gripped at the bulkheads using split cone wedges. What do you mean split cone wedges? Where every wedge is splitted into 2 to 3 pieces anamata. So these wedges are made from tapered conical pins. Why tapered? Why can't it be prismatic? Endukamma wedge anedi tapered ga undi? Why can't wedge will be prismatic? So if the wedge is prismatic, so what happens? It can't hold the wire. It can't hold the wire. Okay, See, for example, if you want to hold any wire in your hand, if someone is pulling wire from your hand, it can easily be come out. Why? Because you are not having a proper grip. Let us hold the wire conical shape. Conical hold cheyandi. Conical in the sense, so here the diameter will be more, here the diameter will be less. You can observe my hand, right? So if you hold your hand like this in a form of a conical shape, by then you can hold the wire with more grip. That is the reason why your wedge is in a form of a conical shape instead of prismatic shape. Prismatic ante enti? Having a same cross section throughout the length. Okay, having a same cross section throughout the length. That members are called prismatic members. Prismatic members ante uniform cross section anamata. Okay, conical shape ante one end will be having less dia, other end will have more dia. Okay, that is how the wedges are made up of conical pins. Flat surface of the pin carries serrations to grip the wire. Okay, so here flat surface of the pin carries serrations to grip the wire. Here if you see the wedge clearly, inside the wedge your surface will be something like a thread laga untundannamata. Okay, you can't expect that your surface is smooth here. Okay, మీరు ఇక్కడ wedge చూస్తున్నారు కదా, yeah, here outside the wedge it is something like a smooth kada, surface చాలా smooth గా ఉంది. But if you see inside, the surface will be in a form of a threading గా ఉంటుందన్నమాట. థ్రెడ్ ఉన్నప్పుడు ఏమవుతుంది, it can able to hold the wire firmly, right? Wire ni chala strong ga hold cheyagalugutundi. So that is the reason why your flat surface of the pin carries serrations to grip the wire. So that is the, you know, I mean, I can call it as devices which are going to be used to do pretensioning. Okay, right. And what is next? Apart from Hoyer method, there is another method to do pretensioning. That another method is called Schorer system under. Okay, ఇది మీ టెక్స్ట్ బుక్ లో కానీ ఈవెన్ మీ కరికులం లో లేదన్నమా. Okay, so just for your kind information, I'm sharing this other system which is gonna useful at some applications. Okay, so which is called Schorer system. In this system, a central tube of high strength steel carries the prestress from surrounding wires, and the entire assembly is placed in position and concreted. Okay, so what is the difference between Hoyer system and Schorer system? Hoyer system lo there are multiple wires which are going to be stressed the whole panel, which are going to be stressed the whole element. But in Schorer system there will be only one central tube, oka pedda tube untundannamata. Okay, so sorry guys, I couldn't able to show image or a video of this Schorer system. Why? Because nowhere it is available. It is only some kind of practical application where people are habituate of using this at some instance. Okay, that's the reason why there is no picture for this. You can imagine how the Schorer system is gonna be adoptable. So there will be a central tube in the mold. Okay, so that tube is consists of high strength steel. Ardhamavutunda? So where that tube is going to be connected with the surrounding wires anamata, right? పక్కనున్న వైర్స్ కి ఈ ట్యూబ్ అనేది కనెక్ట్ అవుతుంది. When you try to pull the center strand which was there in the tube, the other wires are also going to be stressed, right? So that is the way how the Schorer system is going to be adoptable. Okay, so here in Schorer system, after the concrete has attained sufficient strength, the tube is removed and the prestress is transferred to concrete through bond. Okay, so the hole left by the tube is going to be grouted. Okay, here you can reuse of the tube again and again. Why? Because after concreting, after attaining concrete its maximum compression strength, the tube is going to be removed from the mold. After removing, whatever the gap formed between concrete and the wire, that gap is going to be filled with the grouting anamata. Okay, so by that you can make use of that tube again for another elements, right? So in that way the Schorer system is going to be useful even for pretensioning of structural elements. Understand? So this is what about the pretensioning system with the help of Hoyer and Schorer. Okay, Schorer system. So let's talk about what are the advantages of pretensioning system and what are the disadvantages of the system, right? So here let's see the advantage. So here pretensioning system is that there is no expenditure on end anchorages, isn't it? So you doesn't require any kind of bearing cones for doing a pre-tensioning. Why? Because you require bearing cones, springs, sheathing pipes, everything in post-tensioning. In pre-tensioning, you doesn't require any kind of sheathing pipe inside the concrete. దాన్ని మనం duct అంటాం. It doesn't require in pre-tensioning. You doesn't require any kind of bearing cones or bearing plates for doing pre-tensioning. Okay, why? Because for post-tensioning only you require all these kind of materials, right? In pre-tensioning it is so simple, where your strands are going to be stressed, pulled, stretched and anchored at the abutments. That's it. Then after concreting, and you are going to cut the strands. Ade jarugutundi annamata. So that is the reason why in pre-tensioning there is no expenditure of these kind of other materials like end anchorages, rubber cone, metal sheathing. Okay, so which are going to be used in post-tensioning system. And one more thing, there is a greater certainty about the pre-stressing force. Okay, in post-tension members, certainty of force depends on the two end anchorages. Post-tensioning lo pre-tensioning difference ఏంటంటే ఇక్కడ greater certainty of the pre-stressing force ఉంటుంది. It means that you can able to apply the force equally on either side, or by fixing one end you can able to pull the strands on the other end. అలాంటి ఒక biggest advantage మనకి pre-tensioning లో ఉంటుంది. But what happens to post-tensioning, you are supposed to be apply forces equally on either side of the supports, either side of the anchorages. మీకు ఇక్కడ pre-tensioning లో only one hydraulic jack is enough to do pre-tensioning. What happens to other end? Other end is going to be anchored. Only one end you can able to pull and you can stretch the wires. That is how the pre-tension can be takes place. But in post-tensioning you have to apply forces uniformly on either side. Jacks అనేవి మనకి ఇక్కడ 2 jacks కావాలి on either end. Okay, that is how in post-tension you are going to apply forces eventually on two end anchorages. That is why pre-tensioning is having a very good advantage in terms of using materials, in terms of applying force certainly on only one end. Understand? So that is the advantage of pre-tensioning. Let's talk about the disadvantage. What will be the disadvantage in pre-tensioning? The end abutment should be very strong. Okay, what do you mean that? Here you can see in picture, see these are called abutments, right? So if the end abutment is not strong, this abutment is made up of concrete. Okay, this abutment is made up of RCC element anamata. ఇప్పుడు ఈ end abutment strong గా లేదనుకోండి, when you start pulling strand from this end, if the abutment is not strong, what happens? This wire will come out from this anchor లో నుంచి బయటకు వచ్చేస్తుంది. అవునా? So by that, these abutments on two sides, this abutment should be very strong. Okay, see here you can see very clearly one end is anchored, other end is pulling with the help of a hydraulic jack. Okay, so let's see, your abutments are supposed to be strong in pre-tensioning system. That's why it is slightly disadvantage. Okay, and they are going to be provided only in precast factories. Precast factories slowly you can able to see the end abutments on either side of the pre-tensioning element. This naturally limits the size of the member, as large sizes are difficult to transport from factory to site of the construction. By that, loss is more in pre-tensioned members. Why? Because in pre-tensioning you can able to do pre-tensioning of small elements. చాలా చిన్న ఎలిమెంట్స్ మాత్రమే మనం pre-tensioning చేయగలము. You can't do pre-tensioning of bigger elements. Why? Because that is very difficult to transport from factory to site. That is one disadvantage. Another one is loss is more in pre-tensioning members. Pre-tensioning members లో ఎక్కువ losses ఉంటాయి అన్నమాట. Like what I am talking about, like shrinkage losses, creep losses, okay, elastic losses. నేను చెప్తాను కదా, these losses we are going to study in the second module of the second part. Okay, so there you can able to understand what do you mean loss and how the loss is going to be occurred when you are doing pre-tensioning and post-tension. Okay, so here the disadvantage is one, where the end abutments are going to be strong, and the next one is you can't cast bigger elements. Why? Because you can't transport the elements from factory to site of the construction. And the third one is loss is more in pretensioning members. Okay, so these are the disadvantages of pretensioning. That's it. This is what about the methods and system of prestressing. Okay, one is Hoyer system, other one is Schroer system. Okay, so that's it. This is what about the pretension system or pretension method, right? Any doubts in pretensioning? If you have any doubts, you can just text me. In the meantime, I will try to show you another video, so where you can able to understand bit more about pretension.
Although strong in compression, it is weak in tension. For this reason, it needs help in resisting the tensile stresses caused by forces from applied loads, which can result in cracking and ultimately failure. Compressive stresses are introduced in prestressed concrete either by pretensioning or post-tensioning the steel reinforcement. In this video, we will learn about pretensioning. Pretension concrete is a variant of prestressed concrete where the tendons are tensioned prior to the concrete being cast. The concrete bonds to the tendons as it hears, following which the anchoring of the tendons is released, and the tendon tension forces are transferred to the concrete as compression by static friction. Pretension is a common prefabrication technique where the resulting concrete element is manufactured remotely from the final structure location and transported to site once cured. It requires strong, stable, and average points between which the tendons are stretched. These anchorages form the ends of a casting bed, which may many times the length of the concrete element being fabricated. This allows multiple elements to be constructed end on end in the one tensioning operation, allowing significant productivity benefits and economies of scale for this method of construction. The amount of bond or addition achievable between the freshly set concrete and the surface of the tendons is critical to the pretensioning process, as it determines when the tendon anchorages can be safely released. Anchorages can
See, now you can see this is what an anchorage. Okay, anchor and like this is what an abutment, iron steel abutment anamata. Okay, so earlier in the picture you have seen the concrete abutment. Here the steel abutment, which is going to be hold your concrete at both ends. Okay, so you can see the strand which is there inside the mold. Okay, and which is fixed with a single wedge, isn't it? Right, so this is what we are talking about, the anchoring of both either side.
be safely released. Bond strength in concrete allows more economical fabrication at its speed.
See, these are all precast element. Okay, so sorry, precasted pre-tensioned element, right?
Concrete is most commonly used for fabrication or
Will now be
structural floor slabs, hollow core blanks, balconies, those piles, water tanks, and concrete pipes. That's the end of the video. Thank you.
Right, see how many, have you observed how many applications are there for pretensioning? There are lot many. Even in your RCC structure you can go with each individual element into precast pretensioned element. Okay, so in that way he showed few examples like lintel, right, slabs, voided slabs, right, so I mean water tanks, okay, all these, like, you know, columns, piles, driven piles. So these are all going to be your precasted pretensioned elements. Okay, so in that way this Hoyer method is going to be useful to do pre-tensioning, okay, of the particular precasting elements, right? Okay, so now any doubts in pretensioning related to Hoyer method or you know, other method? Any doubts? So if you have any, I mean, if you don't have any doubts, so by that I will continue with the post-tensioning system. Any doubts? Guys, if you have any doubts, so you can ask me. No doubts means we will continue with the next, which is a post-tension. So once explain second method in prestressing. Yeah, see, second method is something like, you know, 1 second. Because if you have a picture, by that Schaurer system. See, Schaurer system is something like, you know, please try to understand the statement. There will be a central tube of high strength steel wire. Okay, let us take, it's a small tube, okay, which is a hollow tube anamata. A hollow tube lo oka steel wire ni place chestaru. Okay, there will be high strength steel wire which is going to be carried in the central tube. And what happens, that tube is going to be connected with the surrounding wires. Okay, pakkana unna wires kuda aa tube connect ayi untundi. Whenever you pull the central tube, I mean central wire which is there in the central tube, along with that wire, the other surrounding wires are also will be under stress. Avi kuda stress avutayi anamata. Okay, so that is how the entire assembly is going to be stressed with the help of a single wire. Oka wire to we can able to do stressing of all multiple wires which are there beside the main central tube anamata. ఎప్పుడైతే స్ట్రెస్సింగ్ అయిపోతుందో, then you can able to remove that tube easily, and when you remove the tube there will be a gap between wire and concrete, isn't it? Okay, wire and concrete gap ni again we are going to fill that with a grouting material. Actually this tube system, like a duct or sheathing system, grouting, this all we do in post tensioning, isn't it? But even you can do it in pre-tensioning with the help of this kind of tubular system, I mean Schaurer system. The Schaurer system dwara you can able to do even, I mean placing a tube, with the help of that tube you can do the multiple wires to be stressed along with the same wire. Okay, then it can be grouted by after removing the tube from the particular mount. Okay, so this Schaurer system with chupichdaniki there is no picture and videos available. Okay, so the information which I known from the applications where people are nowadays using in few applications to make work fast, work and chala fast ga production of elements to be produced more. In that way the Schaurer system are adaptable nowadays. Okay, so that is the reason why I try to explain you this system. But nominally the Hoyer system is the one which is going to be used in all pre-tensioned factories. Okay, so that is how the Schauer and Hoyer systems are optimal. But the application doing the system, everything is same. The only thing is here you will have an additional tube inside which is going to carry the high strength steel which is surrounded with the other steel members also. Okay, so that is how the Schauer system is there. Yeah, understood? So anyone, any doubts? Yes, we will place sandwich plates. Yeah, exactly. So we are going to place the sandwich kind of plates to hold the wire. Yeah, in that way. Since one explains second method in prestressing. Yeah, got it. Anything? Any doubts? Guys, from the first system, if you have any doubts, please ask me now itself, because I'm gonna start with the second. and second one which is a post tensioning. No doubts? Clear? Gopi, your doubts clear? Right. Okay then. Let's go with the second one. So which is a post tensioning system. So here there are four important and popular post tensioning systems are available. One is the Freyssinet system. Next one is Magnal Blaton system, Guilford Udall system, Lee McCall system. So it is very tough to remember these names, but these are the systems which are there for doing post tensioning. Okay. So in examination, so straight away they want to ask you what are the, write down the systems there for post tension. Okay. Or the methods for doing post tensioning. So you have to write all these four. Or sometimes they're going to ask you one particular system, so where you have to answer that system with some pictures also. Okay. So that is how the four methods are available. For the time being, I will try to cover the first system, which is the Freyssinet system now. Let's go to the first system, which is the Freyssinet system. See, I think you all know how the post tensioning is going to be done, right? So let me show you first the post tensioning video, then we will try to explain you the Prestressed system. ఎందుకంటే ముందు ఇమేజ్ ఒకసారి మనం if you have that imagination, then it will be very easy to understand the concept. Okay, ఒకసారి I will try to show you how the post tensioning is going to be done. So that is called form work. Okay, after form work, they will place a reinforcement to make that into a rectangular shape, girder into a rectangular shape. Then the sheetings, this is called sheeting, or it is called a duct anamata. Ive hollow pipes. So this pipe is going to be placed before concrete casting anamata. And you can see all elements here. This is called the spring. So this spring is gonna be useful to allow compression forces into the concrete. ఎప్పుడైతే మనం స్ట్రాండ్స్ ని మనం ఇలాగ పుల్ చేస్తామో, స్ట్రెచ్ చేస్తామో, it will push the concrete towards inside. When it is pushing concrete towards inside, at support, at ends, there should be some kind of shock absorbers. Okay, so why? Because you all know springs always carry compression forces, isn't it? So to sustain the load at the support or at the end, the springs are going to be useful at end diaphragms, and this is called anchorage cone, and there will be a bearing plate, and there will be strands. Okay, and the other formwork is going to close, and they do concrete, right? So this is the difference. Now see, now you can see the wires which are later also you can place, even after casting also you can place the wires. See, what is the thing which is inserting towards the strands? This is called bearing plate, right? After the inserting bearing plates, they are going to insert the hydraulic jack. Sorry, here they forgot to show you one small element, that is fixing the wedges fixed trailer. They forgot in the video, right? So after before placing the hydraulic jack, they are going to place the wedges somehow. Okay, don't forget. Okay, so here wedges will be placed, then hydraulic jack is going to be placed. Here hydraulic jack will be placed on either side of the girder ఇటు ఉంటుంది, అటు సైడ్ కూడా hydraulic jack ఉంటుంది, right? After doing stressing, they are going to be cut, and by placing the caps, they are going to do the grouting. Okay, so this is what the post tensioning process or post tensioning system. Okay, now we will go to our concept. What do you mean Freyssinet system? So here Freyssinet system was introduced by the French engineer. Okay, French engineer called Freyssinet, and it was the first method to be introduced to do post tensioning. Post tensioning cheyadaniki first system was developed by Freyssinet. Then the other systems came into existence. This what it was doing in Freyssinet system a high strength steel wire of having different dias like 5 mm, 7 mm. Okay, so it can be named as 8 or 12. 12, I mean, sorry, 8 or 12, 16, 24, like that. You will have a dias of wires and matter, which are going to be grouped into a cable with a helical spring inside. Okay, so in the video I have showed you one spring, right? So that spring is the form of a helical spring, so which are going to be placed the spring inside. So along with the spring, there will be wires which are going to be placed inside the concrete. So that spring, what is the purpose of the spring? Spring keeps proper spacing for the wire. Cable is going to be inserted in the duct. ఎప్పుడైతే మీరు స్ప్రింగ్ అది helical spring place చేస్తారో, when you are inserting the strands into the concrete, okay, so that spring will try to maintain that space of the wires of the top wire and the bottom wire. ఇందాక మీరు గర్డర్లో చూసుంటారు, there are 3 stages of strands. Top లో ఉంది, middle లో ఉంది, bottom లో ఉంది. So okay, so to maintain that distances, you are going to space one helical spring on every portion, okay, which is going to be spacing, which is going to be useful to maintain the proper spacing of the wires, which are when you are inserting the cables into the duct. Okay, and what you do in the Freyssinet system here, anchorage device which is going to be consist of a concrete cylinder with a concentric conical hole and corrugations on its surface, and a conical plug which is carrying grooves on its surface. So in this picture you can see all which I mentioned in the statement. So here, this is your concrete, and this is your strand, and this is your hydraulic jack. Okay, and this is your hydraulic jack and the wedges, and along with that the strands are going to be provided. Okay, this is the stages of doing the post tension method. All these 4 stages which was mentioned in the picture, right? So the steel wires are going to be carried along these grooves at the ends where the concrete cylinder is heavily reinforced, right? So here in the element it is showing it is something like a concrete cylinder. Okay, but in the practical we are going to do it for beams or for large members and matter, right? So here the members are going to be fabricated with a cylinder placed in position. Wires are pulled by Freyssinet double acting jack. What do you mean double acting jack? The jacks which are going to be provided on either side of the beam. Beam each side jack untundi, other side got jack untundi. Okay, the whatever the video you have seen just now, that video is completely, or that system is completely based on the Freyssinet system only. Okay, Freyssinet double acting jack, which is going to be used for pulling strands, okay, through the bearing cone and bearing plate, where the wires are going to be stretched within the cable at a certain time. Okay, so that is how the Freyssinet system is going to be helpful. Here you can see the elements which are going to be placed in the Freyssinet system. So this is called prestressing steel. This steel will be inserted into the duct or sheathing. This sheathing is going to be fixed to the guide. This guide antaru, lekapothe bearing cone ani kuda antaru. Okay, bearing cone. This bearing cone is fixed with the bearing plate. This bearing plate is having certain holes. Every hole is to be filled with the wedges. Whitney wedges antaru, where the every strand is supposed to be through the wedge only. Wedge dwarane lopaliki insert avvali. Okay, so in this picture you can see individual parts of each element, and adding together it is going to be looks like this. Ivanni add ayin tarvata ila meeku kanipistundi. See, you can see the bunch of strands, sheathing, bearing cone, bearing plate, wedges, strand. Got it? These are all individual. This is the combined element. So here one end of the wire is going to be anchored and the other end is pulled till the wires are stretched to the required length. So here no need to do anchoring at one end. You can do stressing on either end. Okay, that is how the equality of load can be distributed to the concrete easily. Okay, and the inner position is then the jack then pushes the plug into the cylinder to grip the wire. So this is the system, Amma. Just you are going to pull the strands, then the concrete is going to be squeezed into the squeezed with the help of the compression forces. Okay, so in the tomorrow's class I will show you a small model which was developed by me, where you can able to observe how the element is going to be squeezed to get into hog. Adi pike bend avvadaniki ఏ forces apply అవుతున్నాయో I will try to show you in a small model. Okay, so this is how the Freyssinet system is going to be useful. Okay, ఏదైతే మనం ఇందాక వీడియోలో చూసామో the complete system is called a Freyssinet system. Okay, so why? Because that is the first system which was adopted for post tension. Post tensioning cheyadaniki first method Freyssinet system anamata, right? So this is what about the Freyssinet system. And other three methods, Magnell-Blotton method, Gifford-Udall system, and Lee-Meccal system, these are all came into existence after the Freyssinet system. Okay, so what are the drawbacks in Freyssinet system? Why this Magnell-Blotton system came into picture? That you can able to understand when we go into that concept. Okay, right. So that ends with the today's session, Amma. Right. Any doubts? So you can ask me now. Yeah, it's only 3 minutes left. Any doubts in Freyssinet system? So which is the post tensioning method? Any doubts, Amma? If you have any doubts, you can ask me now. Last 3 minutes left for doubts clarification. Industry. Okay, no. What about others? Others also please respond. Clear, everyone? Okay, good. Okay, I will try to show you that small model tomorrow. Okay, before our class, I mean before going into the other systems, then it will be easy for you to understand. Gopi, good, clear, no doubts, right? Anything else? Vamsi Krishna, clear? Right. Okay, guys. Right. See you tomorrow then. Okay. So I shared you the assignment format. You can just type your answers in that format by writing your name and roll number. Okay. And that's it. And rest of everything goes there in the format. Okay. Please go through every question. I have given the word limit, and there is a weightage of each question. Okay. For all these 10 questions, there are weightages, and there is a word limit. You have to write within the limit. And please guys, don't copy from others, because I am going to check the plagiarism, okay, within you. Out of 35 or 40 students, those who are going to write the assignment, I'm going to check your answers within you with the help of a plagiarism software. Okay, so don't copy from others. You write on your own. You copy from your own. Don't copy from other student. Okay, if you copy, I'm gonna caught you, both the guys, and I won't allocate marks to you. Okay, so please don't do that. Please try to spend some time on writing the assignment effectively. Okay, that is what I want to share to you. Okay, so please keep the marks in the group. Okay, sure, Vamsi. I forward yesterday. I will try to put marks now itself. Okay, I will share this presentation along with the attendance, then I will put the marks also in the group. Okay, right. Okay then, guys. Okay, see you tomorrow. Right, stay safe.